Welcome to part 2 of sinusoidal applications. In this application, we have Tarzan the monkey man swinging on his rubber band in order to impress Jane. Now, they got bored with their lives, it seems, and they decided to model trigonometric applications with the real world. While Tarzan swings back and forth on a riverbank, going over land and water, Jane's job is to measure to model this mathematically using a stopwatch. Now, t is going to be in seconds again. That's cool. And y is the distance in meters from Tarzan is from the riverbank. So if y is positive, he is over water. If y is negative, he is over land. So Jane finds that when t equals 2 seconds, Tarzan is at one end of his swing, where y equals negative 23. So if it's negative, so where is he at? He's over land. And at 5 seconds, he reaches the other end, which is 17 meters over water. So they want us to sketch this out. Since we're dealing with negatives, be a little careful. There's time, there's distance. Remember, anything positive is water, anything negative is land. Okay? All right, so graphing this, at 2 seconds, he is at negative 23. Now, at 5 seconds, it's not the period, at 5 seconds, he's at the other end of his swing at 17 meters. Now, what's neat about this one, on the other two, they gave us a complete cycle. We can figure it out. Here, they only gave us half a cycle, or half a period here. So we have to get the rest of it. So 3 seconds to go from one end to the other, another 3 seconds to go back. So at 8 seconds, he's going to be here at the bottom, and if you want to go 11 seconds, he's back at the top of the swing. So if we sketch our graph, we see our sinusoidal function, or pause this if you need to. Part B says, write the equation expressing Tarzan's distance from the riverbank in terms of t. So remember, we're going to use cosine. Y equals A cosine B, t minus c plus d. So we need A, B, C, and D. All right. So to get this one, A, B, C, and D, the first thing we're going to do is we're going to draw our midline. Now, it looks like the midline is probably getting down negative here. So there's my midline. Not perfect, but it gives us the idea. And I need to find its value. Well, I need to find the number halfway between 17 and negative 23. Now, I know they're 40 units apart, so halfway is 20. So that's going to put us at negative 3. So that's our D. Remember, D is our midline. And it also is going to give us A, because A is the distance from the peak to the midline. And the A is, well, 17 feet to go down, plus another 3. A is 20. B, or C, I'm sorry, the phase shift. This is our phase shift, right? This is our phase shift. Remember this, right? C is the distance from the y-axis to the peak for cosine, and that's just 5. And now we have to get our period. This is our period from peak to peak, okay? And the period here is 6 seconds. So we use our period, our formula. Period equals 2 pi over b. So we get 6 equals 2 pi over b. Solving it, 6b equals 2 pi. So b equals pi over 3. And there's our period, which gives me my function now, or not period, but b. So our function is y equals 20 cosine of b t minus 5 minus 3. And there's our function. And now, remember, we're going to type this in our calculator, okay, which I kind of already did for us, except for, clear out what you have in there, sorry, clear what you have in your calculator, 20 cosine. This becomes pi over 3, second pi divided by 3. Remember, you're going to need another set of parentheses here. X minus 5, close it twice, minus 3. Remember, make sure your window matches your graph. Look at your graph. Window, 0, that's cool. Only goes out to 11. I can go out to 15, but sometimes check your numbers here. Yeah, 15 might do well because I need to go out that far. So I might even go out further, make it 20. And my height, it goes from negative 23 to 17. So I might go from negative 25 to 20, just to see the graph all together. And there it is. There's Tarzan. Up, down, up, down, up, down, up. There we go. Now, to answer the next questions, we're just going to use our equation now. So I want to find out y when t is 2.8. So I want to find y of 2.8. And I just use my calculator. Second calc, value, 2.8. And that gives me negative 16.383 feet. Now, but you got to remember, what does this mean? He is over water, or land, sorry. He is over land at this time. Take a look at the next one. 15 seconds. Remember, that's why we had to expand our domain here on our window. Remember, we took our window, made it 20, so we can make sure we can get 15. So second calc, value at 15, and I get negative 13 feet. Again, he is over land. Very good. Now, questions so far? Remember, I'll write them down if you have them, and you can ask tomorrow in class. All right. Now, where was Tarzan when Jane started a stopwatch? That's easy. That's where time equals 0. So it's the same thing. I need y of 0, so nothing changes. Just go second calc, 0, 0, and I hit enter. He's at 7 feet, which is interesting because when she started the stopwatch, he is already over the water. Very good, because it's positive. Very good. Now, after 24 seconds, Tarzan lets go. And the question, will he land on water or will he land on land? Now, but be careful, 24 seconds, we have to change our window. We have to change our window here because our window only goes up to 20 seconds. I need to go to 24, so I might graph it to 25 and let it graph. While that's graphing, remember, after 24 seconds, this is easy. I just now want to find y of 24. Very simple to do. Second calc, 24. Messed up. Second calc, value, 24. Hit enter. He's at 7 feet. So it's positive. It's positive, so therefore he is over the water. Perfect. He will land safely. All right. So tomorrow in class we'll be working on a bunch of these, so I'll see you then. Thank you.